start the recording. Okay, so what we will now look at is how an electric field can be used to accelerate electron. So if electron is positioned here, that means a force has to hold it. Otherwise, it will tend to move in this direction. So if it is, so what it means is at this point, it has got some what we call as electrical potential energy. And if it is allowed to go or it is released, then it will move from here to there, just like you drop a ball and it comes down towards the ground. So, and doing so, as the electron moves from here to the positive plate, it loses its electrical potential energy and it gains kinetic energy. Now, and gain in kinetic energy will be equal to the electrical potential energy. So how much electrical potential energy does it have here? We will start the electron from this side. So if we want to make it move to this side, we will have to apply a force. How much will be that force? Force is equal to E times Q. And it's moved a distance d. So that means work done will be force times distance. So it will be EQ times that distance, EQD. And it's written over here. Okay, so work done will be force times distance, which is EQ times D, and work done changes into electrical potential energy. So if the electron is moved from here to there, from this plate to that plate, it will be gaining electrical potential energy. And how much is the electrical potential energy? It is equal to EQ times D. That's the equation you will be given in your set of formulae. Now we can also replace this D, and because with V, so V is equal to V over D. So if we make V the subject of the equation or replace E by V over D, so it becomes V times Q. And also we already said that if the electron is allowed to move from negative plate to the positive plate, it will be losing electrical potential energy and gaining kinetic energy. So if you are asked what is the speed of an electron when an electron is released from here to there, what you will do is you will calculate the electrical potential energy on this side of the plate. Then you will make it equal to the kinetic energy, and using half mv square, you can calculate the speed. Read these notes also. Now, so that was about accelerating an electron. Electric field can also be used to find the charge on an electron, and that was the famous Millikan-Oldorf experiment that we talked about. So say, for example, if a charged object, we don't know it is positively charged or negatively charged, but it is held in an electric field, and let's say top plate is positive and the bottom plate is negative, then electric field will be from positive to negative, and let's say it is stationary. If it is stationary, that means forces acting on this charged object are balanced. What are the forces? So gravity force is always downward. And because it's an electric field, there will be an electric force which will be upwards. It could be stationary or it could be moving with a constant speed, upwards or downwards, because that's the condition for balanced forces. Object could be stationary or it could be moving with a constant velocity. So that means F electric is equal to Fg. So by doing that, Fg is equal to Fe, and or mg is equal to E times Q. So by using that, Millikan calculated the charge on an electron. And I'm not going to go into the detail of that one, but what he found was that this charge was always a multiple of charge on an electron, 1.6 times 10 to the negative 19. So what it means, what he concluded was that charge, basic charge on an electron is 1.6 times 10 to the negative 19, and it will be similar charge, but opposite charge on a proton. So that is basically for this one. for static electricity. These are the only two main things that you need to know. Is everyone okay so far?
Yeah.
Yeah, okay, we will move on to DC electricity. Now, DC electricity, the main thing in this topic is that you will be asked to apply. These are all the notes that you can read in your own time. You've been given notes, in your during the lessons, and they're also in Google Classroom, but I'm just made a kind of a brief summary. So the main thing that you will be looking at, we will be looking at this one is that what's the relationship between voltage, current, and resistance, and that's the Ohm's law. So if you look in this circuit, that's the resistor where the resistance can be changed. Now, this is the only resistor, so voltage across this one will be same as the voltage of the battery. Now, if say for example, so this battery is providing the voltage, this resistor is using up the voltage, and it will be same. If there were two resistors in series, then again the total voltage across these one will be equal to that one. Okay. If they were in parallel, there were three resistors in parallel, voltage across three will be same as the voltage of the battery. That's the basic rule of the voltages. Now, so if resistance is kept constant and we increase the voltage of the battery, then this voltage will increase. And if the voltage increases, then the current increases. Or in other words, we say that current depends on the voltage. If the voltage across the resistor is more, then the current will be larger. Secondly, if we keep the voltage constant but change the resistance, so that means by changing the resistance is increased, current will decrease. Or we say that current is directly proportional to the voltage, or current is inversely proportional to the resistance. Because if you make I the subject of the equation, that will be V over R. But this is the equation that's given in the formula list. And the gradient of the graph gives you the resistance for the voltage current graph. So that's the basic principle of Ohm's law. What is power? Now, power is how much energy is provided every second by the battery. Or if we talk about the power of a resistor, then it is how much heat is produced by a resistor every second. Now, so power provided the battery is equal to the power used or the heat produced by the resistor. If there are 2-3 resistors in a circuit, then this power will be equal to the power produced by all the 3 resistors. Now, how much is power? Power is generally voltage times current. And total energy is E equals P times T. These are the formulas given. These formulas are not given, but we can derive these one by replacing V here or by replacing I there. So these are the two formulas that you can deduce yourself. Unit for power is joule per second or watts. Now, I just briefly go over. So these are the two main things. So in this DC topic, main thing is applying Ohm's law to a circuit, but it will not be a simple circuit like this one, as we looked over here. It will be a little bit more kind of advanced circuit like this one. So what I will look at is briefly. Now you will be given diagram in this format, not in this format. So let's look at the diagram. So 18-volt battery, current comes out of the battery, it divides between these two resistors, and then it joins back here and goes back into the battery, through this resistor back into the battery. So that means current coming from here will be 3 amps. Now, when you are asked to calculate the total resistance of the circuit, sometimes it is easier to think that these 3 are in parallel, but they are not actually in parallel. Only these 2 are in parallel. So what I've done is I've done this diagram where I've just kind of moved this one over here, because current after passing through these one, joins back and goes into this 2 ohm resistor and then into the battery. So this resistor is actually in series with these two together. So if you're asked to calculate the total resistance, first of all, you will calculate the using 1 over R1 plus 1 over R2. You will calculate the resistance of these one. And then you will calculate add the resistance of that one to the total of these two together, and that will be the total resistance. Okay. Another way that we can just quickly shortcut I'm doing is if I'm asked to calculate the total resistance, is total voltage divided by total current. 18 times 3 is 6. So that resistance has to be 6 ohms to produce a 3 amp current. Okay. Questions that could be asked is, which resistor has the most current passing through it? So if you look, this is easier to see that if we draw it that way. So this 3 amp current is going through this one, and it is 3 amp comes out, and then it divides into 2 branches. So this one has the most current passing through it. Which resistor has the least current passing through it? Now here, current has got 2 paths. More current passes through the smaller resistor. So this one will have more current, and this one will have less current. So this is the resistor which has got the least current passing through it. Another question that could be asked is, what is the voltage across these resistors? It's easier to do it. So voltage is I times R. So 2 times 3 is 6. So this one is using up 6, or we can say this one is using up 6 volts. So this is voltage used up. This is voltage provided. So 18 minus 6 leaves 12. So these two one will be receiving 12 because voltage is same. So 12 volts across here and 12 volts across here. And that what makes 12 divided by 6 makes 1 amp current, and 12 divided by 12, this one makes 12 divided by 6, 2 amp current, and 12 divided by 12 gives 1 amp current. So 3 amps will be dividing. So 2 amp goes through here and 1 amp goes through here. Another thing that you could be asked is, which resistor is producing the most heat energy? So most heat energy is produced. We will need to do some calculations for power, which I have done in this question over here. So for 2 ohm resistor, 3 amp current, and voltage is 6, so 6 times 3 is 18 watts. And the 6 ohm resistor has 12 is the voltage, 2 is the current, 24 watts, and then the this one is for the 12 ohm resistor, it's producing 12. So by comparing these three, we can see that this one is producing the most heat energy. So this is the basic of the DC electricity. You will be given the question in this format, and you will be asked some of these questions which I have listed here. So basically, this is the summary of what you could be asked in static and DC topic. If I can stop sharing this one, let me stop recording first.